Introducing CCM and CAIQ 3.1 learning objectives. After completing this chapter, learners will be able to identify the CSA Cloud Controls Matrix, CCM, and CCM domains. 1. Explain the Consensus Assessment Initiative Questionnaire, CAIQ. 2. Outline CCM and CAIQ structures. 3. Recall CCM relationship with other frameworks, mapping and gap analysis. 4. Compare transition changes from CCM v3.0.1 to CCM v4. 5. 3.2 Overview. Chapter 3 focuses on the CSA Cloud Controls Matrix, CCM, and the Consensus Assessment Initiative Questionnaire, CAIQ. This chapter explains their purpose, why they were created, their objectives and the relationship between CCM and CAIQ. It also covers their connection with the CSA Security Guidance, hereafter referred to as the Guidance, and the CSA Enterprise Architecture Model, together with their role within the context of the Security, Trust, Assurance, and Risk program. It gives an overview of their target audience and how each audience is meant to use CCM and CAIQ. It provides guidance on the mappings of CCM controls to other industry-accepted security standards, regulations, and frameworks, with examples. This chapter introduces the 16 CCM domains, the 133 control objectives of CCM v3.0.1 and their relationships with the questions of the CAIQ. 3.3 The CCM and how it was created. The Cloud Controls Matrix, CCM, is a security control framework that is dedicated to managing risk in the cloud. It was developed to address the lack of a cloud-relevant security and compliance framework, because, at the time of its creation, risk management was solely focused on addressing traditional computing infrastructure. The CCM is meant to fill this gap, by helping guide both cloud service providers, CSPs, and cloud customers assess the overall security risk of a cloud service. For CSPs, the CCM is meant to establish best practices to support the secure implementation of cloud infrastructure and services. For cloud customers, the purpose is to enable them to better evaluate and assess CSPs. The CCM includes detailed security concepts and principles that are aligned with the CSA Security Guidance v4. 183.1 This document provides guidance on how security principles and criteria should be implemented in a cloud architecture, whereas the CCM provides guidance on what should be done. The CSA encourages organizations to use the CCM as a companion to the CSA Security Guidance, because it allows the user to identify security controls and understand how they should be implemented. 3.3.1 How it was created. The CCM is both vendor-independent and consensus-driven. Like many other frameworks, CCM is the result of the contribution of security experts who volunteer for the CCM Working Group, WG. Since its initial publication in 2010, more than 300 experts have contributed to versions of CCM, and more than 500 have participated in the peer review process. Within the CCM Working Group, the decision-making process is mainly based on consensus, which won 183 Cloud Security Alliance, Security Guidance v4.0, July 26, 2017, https://cloudsecurityalliance.org/research/guidance 180 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance. Means that each control objective reflects the shared and common opinion of the experts on a specific technical aspect of cloud security. After the building process is finalized, the CCM goes through an open peer review process, which is part of the standard CSA research lifecycle. 184.2 The CCM is very resilient, because it is an open framework subject to public scrutiny. Anyone who has the expertise can review and critique it during open peer reviews, making it a very resilient framework. At the same time, the process of collecting input remains open at any time. Because the CCM is a free framework, anyone can download and comment if they see areas for improvement. The CCM change process is triggered by technology evolution, process improvement, or the introduction of new laws, regulations, or technical frameworks. The change process can be triggered by the CSA internal stakeholders, working group members, CSA corporate members, CSA chapters, or external experts. Change requests are evaluated by the working group and might be accepted. CCM Release Overview. There are three forms of CSA CCM releases. A full or major release, i.e., v3.0 rightward arrow v4.0, entails the following: a revision of the CCM domain structure, a technical change, revision, addition, or deletion, of a number of controls greater than 10%, compared to the previous full release. A. Release, i.e., v1.0 rightward arrow 1.1, constitutes the following forms of CSA CCM modifications: a change in the matrix column, a technical change of number of controls smaller than 10%, a minor release, i.e., v3.0 rightward arrow v.3.0.1, constitutes the following forms of CSA CCM modifications: an editorial change in the controls, updated control framework mapping, revisions to previously published mapped control frameworks, new control framework mapping, introduction of new control frameworks mapped to previously published CSA CCM controls. 3.3.2 CCM versions. Version 1 of the CCM was created in 2010. There were several minor updates made to this version until 2014, when there was a major update from version 1 to version 3. Version 2 was skipped because CSA had released version 3 of the Security Guidance in 2013 and wanted to align the CCM with the new guidance. At the end of 2014, CSA released version 3.0.1. This is the standing version 185.3 with some minor revisions and additional mappings. A comparison of version 1 and version 3 shows the following new domains were added to improve the alignment between the CCM and the guidance: mobile security, supply chain management, transparency, and accountability, interoperability, and portability. 184 Cloud Security Alliance, Research Lifecycle, https://cloudsecurityalliance.org/research/lifecycle 185 as of October 2020 181 Certificate of Cloud Auditing Knowledge Study Guide. The type of organization, CSP versus customer, the nature of its business, its size, large corporation versus small company, or cloud delivery model, IaaS versus PaaS versus SaaS. The CCM can be used to define, implement, and enforce its security requirements and monitor their implementation. The CCM assists companies in translating their internal organizational, operational, and legal stipulations into a standardized set of cloud-relevant policies, procedures, and technical control objectives. The CCM is also a tool for internal and external assessments or audits. It is designed to be used in alignment with the Consensus Assessments Initiative Questionnaire, CAIQ, which provides a set of yes or no questions that can be answered to determine if the CCM controls are being met. Both documents help auditors understand if an organization is following its internal governance policies and fulfilling its legal and regulatory obligations. For example, an organization, based on its internal risk assessment, might identify the need to protect the confidentiality, integrity, and availability of information related to the manufacturing process. The datasets have different levels of sensitivity and criticality. They are stored in a cloud database and are processed in several cloud-based applications. The organization can use the CCM to identify specific policy, procedural and technical requirements, and define control objectives that will be included in the organizational security program. It uses those control objectives to enforce the requirements vis-a-vis the internal users, the business partners and the CSPs, and to monitor adherence to both internal policies and external compliance requirements. CCM target audience. The CCM was created to help cloud customers, cloud service providers, and auditors and consultants. Cloud customers. The CCM allows cloud customers to build a detailed list of requirements and controls they want their CSP to implement as part of their overall third-party risk management and procurement program. It also helps normalize security expectations, provide a cloud taxonomy, and improve understanding of the security measures implemented in the cloud supply chain. Because the actors within a cloud supply chain are independent organizations, each has its own way of expressing and representing its security requirements. It might use a different vocabulary or apply policies that differ from others. In such a context, it is of paramount importance to define a taxonomy, or a set of agreed-upon terms, to normalize the different languages. That is why CCM plays a key role, and why more overarching frameworks are necessary to simplify interoperability. Cloud customers can use the CCM controls to do the following: map organizational, operational, and legal requirements to control objectives. Build an operational cloud risk management program. Build a third-party risk management program. Build an internal and external cloud audit plan. When an organization is building a cloud risk management program, the CCM can help it measure, assess, and monitor the risk associated with a CSP or a particular service. It allows a customer to understand the gaps between its own security needs and the CSP security capabilities. The customer can then use it to identify the compensating controls to close the gap between the organization's needs and the provider's offerings. When building a third-party risk management program, the CCM allows customers to assess a cloud service during the overall service life cycle. It can be used to make the initial evaluation of the service before its acquisition. 182 Certificate of Cloud Auditing Knowledge. Compare offerings from different CSPs, and monitor alignment with internal requirements during the service execution. Cloud service providers, CSPs. The CCM serves multiple purposes for CSPs. First and foremost, it offers cloud-specific, industry-validated best practices they can follow to guide their internal security programs. In addition, it offers standardized language that the CSP can use to communicate with its customers and business partners. The CCM mapping feature provides the opportunity to show alignment with other recognized international, national and industry frameworks, and compliance with the CSA STAR program, which relies on CCM as one of its foundational frameworks. See Chapter 9 for more details. The CSA STAR program allows organizations to be more transparent and reduce the number of security questionnaires they must provide for individual customers. One way they can do this is by completing the CCM Extended Question Self-Assessment, the Consensus Assessment Initiative Questionnaire, CAIQ, and submitting it to the CSA STAR Registry, a free, publicly accessible registry that documents the security controls provided by CSPs. CSPs can use the CCM controls to do the following: build an internal security program based on mature and industry-recognized best practices, facilitate communication and interoperability with business partners and customers, demonstrate commitment to security and transparency about its security posture, streamline compliance by leveraging the mapping between CCM controls and the controls in other international, national and industry frameworks, reduce the time and effort spent in addressing customer questionnaires, demonstrate commitment to security to regulators by adhering to the CSA STAR program. See Chapter 9, build a cloud internal and external audit plan. Auditors and consultants can use the CCM to guide their clients in designing, planning and executing activities dedicated to cloud customers, and CSPs, consultants and auditors can leverage CSA to do the following: help organizations assess their cloud maturity, establish controls aligned with the CCM, compare organizations with market peers through benchmarking. 3.3.4 Key features of the CCM. This section describes key features of the CCM. Mappings to other industry accepted standards, regulations, and frameworks, internal control programs and control reports. An important aspect of the CCM is that it maps to other security standards, regulations, and frameworks. When the CCM was created, there were already a number of other information security standards, best practices, and 183 Certificate of Cloud Auditing Knowledge Study Guide. Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description: image for page with label 183. Regulations in existence, example ISO/IEC 27001 and 27002, PCI DSS, NERC CIP, BITS, BSI. Many companies already had their internal structures and frameworks set up and aligned with those standards. The CSA wanted to provide cloud sector-specific controls and also make sure that organizations had a clear path to connect their existing control frameworks and programs with the new cloud-relevant controls included in the CCM. It, therefore, built all the controls created in the CCM as an extension of existing framework controls. CSA did this by creating a mapping, or a linkage, between a control and a framework, example ISO 27001, and the CCM. The CCM builds on top of the framework to provide a control that is specific to the cloud sector. It then takes this one step further by ensuring that controls are linked to a specific area within a cloud architecture. It helps to identify if a specific control is relevant for IaaS versus PaaS versus SaaS, for example. Because the CCM creates links through mapping, it provides an initial internal control system that identifies which controls should be put in place to further the cloud journey and implementation of an organization. Another important aspect of the CCM is that it provides direction for organization control reports. For instance, if an organization needs to demonstrate to its board of directors, authorities, regulators, or internal/external auditors how it adheres to specific security requirements, it will need to structure a report according to certain security principles. The value of the CCM is that it already provides a structure for reporting. See section 3.7 for more details about the CCM mapping to other frameworks, best practices, and regulations. Connection with the CSA Enterprise Architecture Model. The CSA Enterprise Architecture, EA, is a high-level conceptual model that includes a methodology and a set of tools. It enables security architects, enterprise architects, and risk management professionals to assess the status of their internal IT and cloud providers in terms of security capabilities, and it helps them create a roadmap to meet the security needs of their business. The CSAEA identifies a comprehensive set of functional capabilities and processes grouped in domains. The actions included in each domain are based on best practice architecture frameworks. For example, Sherwood Business Security Architecture, SABSA, defines security capabilities from a business perspective. Information Technology Infrastructure Library, ITIL, defines the capabilities needed to manage the IT services of the company, and thus the security capabilities necessary to manage those services securely. Jericho Forum defines technical security capabilities that arise from the reality of traditional data center technology environments, shifting to one where solutions span the internet across multiple data centers, some owned by the business and some used purely as an outsourced service. Open Group Architecture Framework, TOGAF, provides an enterprise architecture framework and methodology for planning, designing and governing information architectures, and thus provides a common framework to integrate the work of the security architect with an enterprise architecture. The Cloud Controls Matrix creates a connection with the CSA enterprise architecture or any enterprise architecture model by making sure that the controls are linked to a specific area within a cloud architecture. Because the CCM is mapped to existing security controls specifications from various legal and regulatory frameworks, and because that same matrix is mapped to the security capabilities of the architecture, it is easy for a company to assess which capabilities are in place for compliance with applicable regulations and best practice frameworks. 184 Certificate of Cloud Auditing Knowledge Study Guide Copyright Foundation for the CSA STAR program. Within the CSA ecosystem, the CCM provides the foundational framework for the security, trust, assurance, and risk STAR program by outlining security controls that a provider should meet to comply with the STAR program. See Chapter 9 for more details about the role of the CCM in the STAR program. Connection with existing information security control environments. The CCM provides structure and clarity around cloud security for all organizations regardless of their size or level of maturity, as follows. Organizations new to cloud with mature security programs. These are organizations that are already adhering to non-cloud specific frameworks and have implemented internal security controls to satisfy their needs and requirements. For them, the CCM provides the required cloud perspective and understanding of how to connect the existing control environment with the newly implemented cloud services. Organizations with a cloud-first strategy. For these enterprises, the CCM provides guidance on how to increase the level of maturity and integration between their on-premises and cloud control environments. Smaller businesses or startups. For organizations looking for guidance on how to build a cloud security program, the CCM provides a structure to use without reinventing the wheel. Rather than trying to discover which security requirements pertain to them, they can use the CCM controls. Control ownership. The CCM clearly delineates control ownership. One of the key differences between on-premises infrastructure and cloud computing is that the cloud creates the need for a shared responsibility model. The CCM is structured so that it assigns the responsibility for controls implementation to either the CSP or the cloud customer, or both. This is especially important since one of the most common mistakes in cloud computing is not fully understanding the shared responsibility model. Cloud service model applicability of the controls. The responsibilities for implementing security controls in cloud computing largely vary depending on the service model, IaaS, PaaS, SaaS. See Chapter 1 for more on this topic. It is also covered in the Certificate of Cloud Security Knowledge, CCSK, course. Some controls clearly are the province of the IaaS providers, for example, data center security-related controls, whereas other controls are applicable to any service model, example identity and access management. The CCM defines the relevance of each control to the three cloud delivery models, helping users to understand what is relevant, and when. Security expectations, and security measures implemented in the cloud supply chain. Cloud computing has a complex supply chain with many actors working together. A cloud customer might have multiple IaaS providers and hundreds, or even thousands, of SaaS providers. For all actors in the supply chain to understand one another, everyone needs to have a standard language that uses the same vocabulary. The CCM meets this need by providing a standard taxonomy. 185 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 185. Note, the CCM provides a lingua franca, a language understandable by everyone. This is especially important in a complex supply chain like the cloud, with multiple different actors involved and potentially multiple different sets of security controls. 3.3.5 Relationship between CCM and the security guidance. This section describes the relationship between the CCM and the security guidance. What is the security guidance? The flagship CSA document is the CSA Security Guidance for Critical Areas of Focus in Cloud Computing v4.0. 186 For this document acts as a practical, actionable roadmap for individuals and organizations that want to safely and securely adopt the cloud paradigm, making it a good starting point for professionals who want to learn more about cloud security considerations. Use of the CCM versus the security guidance. The guidance provides a set of best practices and recommendations for how to secure the cloud, whereas the CCM provides a set of control objectives against which an organization should assess cloud security. The guidance essentially explains how to do things in the cloud, and the CCM explains what to do by identifying specific controls. The guidance is structured in domains, similar to the CCM, and focuses on many of the same key areas of cloud computing. 14 domains cover the key concepts of cloud computing and architecture. Higher-level domains address cloud governance and enterprise risk management. There are domains for legal and regulatory compliance, key discovery, compliance audit management, and governance. Following the high-level domains, the guidance drills down to more technical domains, such as management plane and business continuity, infrastructure security, and incident response. The difference in domain structure. There is a substantial alignment between the security guidance, 14 domains, and the CCM, 16 domains. However, the alignment between the two documents is not perfect for several reasons. First, some guidance domains, such as CHAP3, are not suitable controls domains. Also, CSA wanted to be sure that the CCM reflected the body of knowledge gained from working groups created after the guidance document was released. Domains included in CCM v3 that do not map directly to the security guidance follow. Mobile security. CSA had set up a new working group to research mobile security after the guidance was published and wanted to make sure its findings were included in v3. Supply chain management, transparency, and accountability. CSA considered it important to include a specific reference since these are key differentiators between on-premises and cloud computing. 3.4 CCM domains. This section describes the CCM domains. For 186 OPCIT Cloud Security Alliance, Security Guidance v4.0 186 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. 3.4.1 Control Domains. The CCM v3.0.1 is structured into 16 security domains and 133 controls. Figure 3.1. The 16 domains were based on the guidance document and inspired by major frameworks, such as ISO/IEC 27001 and ISO/IEC 27002. The domain defines what category the controls fall under. CCM was deliberately designed like existing non-cloud leading information security frameworks to leverage familiarity with those existing frameworks. The CCM security domains are outlined in Figure 3.2. Figure 3.1 CCM v3.0.1 Structure Domain 16 Domains 133 Controls Figure 3.2 CCM v3.0.1 Structure ACE Application and Interface Security AAC Audit Assurance and Compliance BCR Business Continuity Management and Op Resilience CCC Change Control and Configuration Management DSI Data Security and Information Lifecycle Management DCS Data Center Security EKM Encryption and Key Management GRM Governance and Risk Management HRS Human Resources Security IM Identity and Access Management IVs Infrastructure and Virtualization IPY Interoperability and Portability MOS Mobile Security SEF Secretary Incident Management, eDisk and Cloud Forensics STA Supply Chain Management, Transparency and Accountability TVM Threat and Vulnerability Management Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 187 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 187. 3.4.2 Application and Interface Security. The Application and Interface Security domain focuses on two key components of the cloud ecosystem, software applications and their user interfaces. Application security covers the design, threat modeling, development, delivery, implementation and maintenance of production applications. This is a rapidly evolving area. See Chapter 8 on DevOps. Cloud computing is one of the biggest drivers for these changes from the technical and organizational perspective, resulting in the need for a more mature approach to application security. Cloud computing providers expose a set of software interfaces, or application programming interfaces, APIs, that customers use to manage and interact with cloud services. An API is a set of routines, protocols, and tools for building software applications. A good API makes it easier to develop software by providing many of the building blocks. A programmer then puts the blocks together. A large percentage of data exposures are the result of attacks at the application layer, particularly for web applications. Most large data breaches are a result of poor application security. Cloud-based software applications require a design rigor similar to an application connecting to the raw internet. The threats in a cloud environment will be more numerous than those experienced in a traditional data center. APIs are a major concern because security, privacy, and availability of general cloud services are dependent upon the security of basic APIs. Provisioning, management, orchestration and monitoring are all carried out using these interfaces. Organizations and third parties often build upon APIs to offer value-added services to their customers. This increases risk, as organizations may be required to relinquish their credentials to third parties to enable their agency. For example, insecure APIs were blamed for successful attacks on Pinterest and Instagram. API vulnerability also played a role in the breach at messaging firm Snapchat, which exposed the phone numbers and names of up to 4.6 million users. 1875 Some of the major API attack vectors include bypassing authentication defenses, bypassing data validation via third-party APIs, evading detection of brute force authorization, evading rate limits, and abusing content types. The CCM application and interface security domain is mainly a reflection of the application security domain of the CSA Guidance v4. Following are controls: ACE01 Application Security, ACE02 Customer Access Requirements, ACE03 Data Integrity, ACE04 Data Security/Integrity, 3.4.3 Audit, Assurance, and Compliance. Audit, assurance, and compliance have always been critical areas in information security. Their importance is emphasized in Chapter 1 and Chapter 2 of this study guide. Having a clear understanding of compliance requirements and obligations and the level of assurance expected or demanded from customers is of paramount importance for CSPs. Failing to implement an auditing plan can have a substantial negative impact in terms of loss of control. And 5187 Snapchat hack leaves phone numbers of 4.6 million users partially exposed. Wired, January 2, 2014. https://www.wired.co.uk/article/snapchat-hacked 188 Certificate of Cloud Governance, lack of compliance, and ultimately financial, operational, and reputational damages. The focus of compliance is alignment with internal policies and external requirements, example law, regulation, industry frameworks. Examples of regulatory compliance laws and regulations include the EU's GDPR, PCI DSS, HIPAA, and the Sarbanes-Oxley Act, SOX. Organizations, especially large ones, are expected to comply with an increasing number of industry frameworks. However, frameworks are often based on the same underlying principles, except ones like HIPAA or HITECH, which are specifically focused on healthcare data. If an organization effectively implements the requirements of some of these frameworks, it will fulfill many of the requirements found in other frameworks as well. For example, physical security, such as controlled access points for data centers, is a requisite in most of these frameworks, and if the CSP follows ISO/IEC 27001 or PCI DSS, the requirement will be fulfilled. Given this, the policies should be designed and implemented in such a way that compliance is not an inhibitor of organizational effectiveness, but a complement to internally determined policies. Cloud customers, especially small organizations leveraging cloud services, have the potential advantage of inheriting compliance from the cloud provider, limited to the scope of service. Even so, the customers remain accountable for their compliance and should always perform their due diligence by reviewing the results of third-party audits and examining the value of existing certifications and attestations. As the number of rules has increased, regulatory compliance has become more prominent in a variety of organizations. The trend has led to the creation of corporate, chief, and regulatory compliance officer roles whose sole focus is to make sure the enterprise conforms to stringent, complex legal mandates. The CCM audit, assurance, and compliance domain is mostly a reflection of the compliance and audit management domain of the CSA Guidance v4. Following are the controls: AAC01 Audit Planning, AAC02 Independent Audits, AAC03 Information System Regulatory Mapping, 3.4.4 Business Continuity Management and Operational Resilience. Traditionally, the three tenets of information security are confidentiality, integrity, and availability. Business continuity deals with the availability component of those three requirements. It refers to the capability of the organization to continue delivering products or services at acceptable predefined levels following a disruptive incident. ISO 22301:2019, Point 1886. Business continuity is often described as common sense. It is about taking responsibility and enabling the organization to stay on course regardless of the storms it is forced to weather, i.e., the ability to keep calm and carry on. This means building and improving resilience in an organization. It starts with identifying key products and services and the most urgent activities that underpin them. Once that analysis is complete, it is about devising plans and strategies that will enable the organization to continue business operations and make a quick and effective recovery from any type of disruption, whatever its size or cause. 1897 Business continuity has often been hailed as one of the biggest benefits of cloud computing, given the very nature of the cloud and the possibility of quickly scaling up and down. However, the concept of IaaS always being available hides substantial risk. 6188 ISO 22301:2019 Security and Resilience. The fact that many cloud services have a track record of being offline only for a few hours a year or so is testament to their overall reliability, but customers should not become complacent. Even the biggest and most reliable computer services in the world are not infallible. Over the past few years, there have been several examples of IaaS provider outages that forced their customers offline. 1908, 100, and 91.9 For a cloud customer, the transition to a CSP must include an assessment of the uptime the provider contractually commits to. However, the service level agreement, SLA, may not be enough to satisfy the customer. Cloud customers need to factor in that a cloud-based infrastructure will experience downtime at some point, and there needs to be a failover mechanism of some kind to cope with it. Customers need to build operational resilience into systems and assume that a failure of some IT component in the application stack is inevitably going to happen at some point. Although many recommendations focus on documented assertions that a service will maintain continuity, the true test of these assertions takes place during a significant incident. Without waiting for an actual disaster to occur, the customer should stress the importance of getting formal confirmation of the business continuity plan/disaster recovery, BCP/DR, tests, and whether the tests satisfied the SLAs contractually committed. A customer should do the following: review the contract of third-party commitments to maintain continuity of the provisioned service. The customer should also strongly consider further analysis. Review third-party business continuity processes and certifications. Coordinate a joint exercise with the CSP to test the customer's BCP/DR plan. Ensure that it receives confirmation of any BCP/DR tests the CSP undertakes, including results and lessons learned. Conduct an on-site assessment of the CSP facility to confirm and verify the asserted controls it uses to maintain the continuity of the service. A CSP should do the following: implement fast SLA-based data recovery. IaaS providers should have contractual agreements with multiple platform providers and have the tools in place to rapidly restore systems in the event of loss. Ensure incremental backups to frequently update a replica of all protected systems or snapshots at intervals set by the user for each system, so the consumer can determine the settings according to recovery point objectives. Make full site, system, disk, and file recovery accessible via a user-driven, self-service portal that allows the user the flexibility to choose which file, disk, or system to recover. Negotiate the SLA up front and ensure that the customer pays for the SLA required to avoid conflict of interest. Consider adopting the most stringent requirements of any customer as a security baseline to maintain systems, facilities, and procedures at a high level. The controls in the CCM Business Continuity Management and Operational Resilience domain are based on the Business Continuity section of Domain 6 in the CSA Guidance V4, Management Plane and Business Continuity. Following are the controls: BCR01 Business Continuity Planning, BCR02 Business Continuity Testing, 8190 SING, M. BCR03 Data Center Utilities/Environmental Conditions, BCR04 Documentation, BCR05 Environmental Risks, BCR06 Equipment Location, BCR07 Equipment Maintenance, BCR08 Equipment Power Failures, BCR09 Impact Analysis, BCR10 Policy, BCR11 Retention Policy. 3.4.5 Change Control and Configuration Management. Configuration change controls for organizational information systems involve the systematic proposal, justification, implementation, testing, review, and disposition of changes to the systems, including system upgrades and modifications. 19210 Configuration management is a collection of activities focused on establishing and maintaining the integrity of products and systems through control of the processes for initializing, changing and monitoring their configurations throughout the system development lifecycle. 19311 A key component of a cloud security program is a rigorous change and configuration management system, including policies, procedures, and technologies for managing the risks associated with applying changes to business-critical or customer/tenant impacting assets, including applications, systems, infrastructure, and configuration. When considering change and configuration management, following are some key questions that any cloud actor, CSP, customer, or auditor should keep in mind: who can request changes? Who can approve changes? Who can develop changes? Who can test the changes for compliance with approved specifications? Who can move the changes into production? Some important requirements follow: restrict programmer access to the production software and data to emergency basis only. This recommendation applies to developers for both CSP and CSC. Ensure that programmers cannot make uncontrolled changes to the source code's production version. See the DevOps section in Chapter 8 in this study guide for further elaboration on this topic. Auditors need to check whether separate test environments exist so that development, testing, quality assurance assessments, staging environments, and production activities are segregated by their functions. Auditors need to review the following: if the source or object code is synchronized with the production code, if there is a production installation plan with an uninstallation contingency plan. The organization and the auditors should evaluate if the CSPs use configuration management tools to enable the following: storing information about versions and builds of the software and testware. 10192 NIST, National Vulnerability Database, HTTP. Traceability between software and testware and different versions or variants, tracking which versions belong with which configurations, example operating systems, libraries, browsers, building and releasing management. Baselining, example all the configuration items that make up a specific release, access control, checking in and out. In the Guidance V4, there is no dedicated domain on change control and configuration management. The controls of the CCM change control and configuration management domain refer to guidelines included in several of the guidance's domains, primarily in Domain 6, Management Plane and Business Continuity, 7, Infrastructure Security, 8, Virtualization and Containers, and 10, Application Security. Following are the controls: CCC01 New Development / Acquisition, CCC02 Outsourced Development, CCC03 Quality Testing, CCC04 Unauthorized Software Installation, CCC05 Production Changes. 3.4.6 Data Security and Information Lifecycle Management as defined in the Guidance V4. The data security lifecycle includes 6 phases from creation to destruction, create generation of new digital content, or the alteration / update / modification of existing content. 1. Store commission of digital data to a storage repository, in most cases nearly simultaneous with creation. 2. Use viewing, processing, or otherwise using data in some sort of activity, not including modification. 3. Share making information accessible to others, such as between users, to customers, or to partners. 4. Archive taking data out of active use and placing it in long-term storage. 5. Destroy permanently destroying data using physical or digital means, example crypto shredding. 6. The relevance of the cycle when defining security control objectives is that it offers guidance on how to govern data during each step of accessing, processing and storing. Such a structured view and approach to data management is of critical importance since data breaches in their various forms, example loss of archives, unauthorized access, malicious disclosure, unsecure deletion, processing not in compliance with applicable laws and regulations, are considered the number 1 risk in cloud computing. 19412 The CCM Data Security and Information Lifecycle Management domain aligns with the recommendation and guidelines included in Domain 5, Information Governance, of the guidance. Following are the controls: DSI01 Classification, DSI02 Data Inventory / Flows, DSI03 E-commerce Transactions, DSI04 Handling / Labeling / Security Policy, DSI05 Non-Production Data. 12194 Cloud Security Alliance, Top Threats to Cloud Computing, Egregious 11, August 6, 2019, https://cloudsecurityalliance.org/artifacts/top-threats- to Cloud Computing, Egregious 11/192 Certificate of Cloud Auditing Knowledge Study Guide, Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 192. DSI06 Ownership / Stewardship, DSI07 Secure Disposal. 3.4.7 Data Center Security. The security of a modern data center must cover physical security, network security, and data and user security. In addition, there are physical security requirements related to offices and working facilities in general. While physical security is an area often considered only marginally related to cloud computing, since it mainly pertains to the responsibilities of IaaS and hosting providers, it is important for cloud customers to do the following to avoid unpleasant surprises. Apply the necessary due diligence to verify that the provider applies adequate physical security measures. Take responsibility for the physical security in the working environment under the customer's direct control. In general, when it comes to data center and physical security, particular emphasis should be given to asset classification and management, access control systems, physical and remote access, identification of the equipment, the possibility of using location-aware technologies, ingress and egress policies, and access logging. The CCM Data Center Security domain covers physical security controls and includes the following measures: classifying tangible assets in terms of business criticality and data sensitivity, implementing physical security perimeters to safeguard personnel, data, and information systems, policies and procedures for the relocation or transfer of hardware, software or data/information to an offsite or alternate location, the use of location-aware technologies to validate connection authentication. Integrity policies and procedures for the secure disposal of equipment used outside the organization's premises, policies and procedures for maintaining a safe and secure working environment in offices, rooms, facilities, and secure areas, storing sensitive information, control and monitoring of ingress and egress points of entry to prevent unauthorized access to facilities. It should be noted that the controls included in the CCM Data Center Security domain do not have a dedicated corresponding domain in the guidance. Following are the controls: DCS01 Asset Management, DCS02 Controlled Access, DCS03 Equipment Identification, DCS04 Offsite Authorization, DCS05 Offsite Equipment, DCS06 Policy, DCS07 Secure Area Authorization, DCS08 Unauthorized Persons Entry, DCS09 User Access. 193 Certificate of Cloud Auditing Knowledge Study Guide, Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 193. Encryption and key management. Encryption is the conversion of plain text to ciphertext using a cryptographic algorithm. 19513 Key management includes activities involving the handling of cryptographic keys and other related security parameters, example initialization vectors, and passwords, during the entire life cycle of the keys, including their generation, storage, establishment, entry, and output, and zeroization. 19614 Cryptography is an essential resource when it comes to protecting data and information. It mitigates the risk of unauthorized access to confidential or regulated data, for instance, personal data, and ensures control over data integrity and repudiability. The development, implementation, and maintenance of encryption and key management policies, procedures, and techniques are critical to secure data in transit, in use, and at rest. This is true in any data processing, storing, and transferring environment, including the cloud. Encryption options vary in cloud computing, largely depending on the specific service model, provider, and application/deployment model. Customers should ask 2 essential questions: where is the encryption taking place? For IaaS, is it on the client side, server side, proxy? For PaaS, is it on the application layer, database, etc.? For SaaS, is it provider managed, proxy managed? Who is managing the keys? CSP, customer, third party. Depending on the answers to these questions, the set of technical controls to be implemented can vary largely. Nevertheless, there are some key controls that should be in place regardless of the specific environment and implementation scenarios, including the following: defining and implementing encryption and key management roles and responsibilities using cryptographic libraries certified to approved standards. Example FIPS 140-3, applying encryption based on data classification and risk following standard change management procedures, implementing, logging, and monitoring the key lifecycle. Management auditing encryption and key management systems and policies, implementing procedure for keys rotation and revocation. The CCM encryption and key management domain aligns with the recommendations and guidelines included in Domain 11, Data Security and Encryption, of the guidance. Following are the controls: EKM01 Entitlement, EKM02 Key Generation 13195 NIST Computer Security Resource Center, Glossary, https://csrc.nist.gov/glossary/term/encryption 14196 NIST Computer Security Resource Center, Glossary, https://csrc.nist.gov/glossary/term/key_management 194 Certificate of Cloud Auditing Knowledge Study Guide Copyright 20 EKM03 Sensitive Data Protection, EKM04 Storage and Access 3.4.9 Human Resources Security. The human factor is a key element in the development, implementation, provisioning and management of technology. Human resource, HR, management has to do with the rules, practices, and actions that aid employees in effectively and efficiently participating in enterprise activities. Human resource management is about establishing, documenting, communicating, implementing, enforcing and maintaining policies, procedures, and tools. Human resource security is a key area in cybersecurity management, and in cloud security in particular. It has consistently been a factor in data breach reports 19 HRS 10 User Responsibility HRS 11 Workspace March 4, 10 Identity and Access Management Cloud computing heavily impacts identity and access management as a security domain, mainly due to the increased complexity and increased exposure of the cloud computing model. The increased complexity results from the cloud imposing shared responsibilities, collaboration, and trusted relationships between multiple parties, i.e., between the IaaS, PaaS, and SaaS providers, the end users and the identity providers. Such complex relationships are further complicated by the fact that very often an organization uses hundreds, if not thousands, of different services. The increased exposure risk is related to the very nature of the cloud. The accessibility of services through the internet dramatically increases the risks of credential theft, impersonification, and account takeover. For example, to properly implement IAM controls, an organization needs to map identities, such as a person, a device, an application, any other software, a virtual machine, to some attributes, example the role within the company, the location of a server, the function of a piece of code. It is then necessary to define the right privileges associated with the identities. The risks associated with IAM are that all of this takes place within a complex supply chain that includes several third parties that are not under the direct control of the organization, possibly using different systems and technologies. An identity mapping exercise would need to be coordinated within a defined service architecture that adopts identity federation by leveraging the right frameworks. Other factors further complicating the IAM approach: management of privileged users, management of third parties' employee-owned devices. Due to BYOD policies, following are examples of measures an organization should have in place in order to mitigate the risks related to IAM: establish, implement, enforce, and maintain policies and procedures to manage information about the identities of who accesses data and enterprise-owned assets, and to determine their level of access. Review and update policies and procedures regularly. Enforce an authorization process based on the principles of least privilege and segregation of duties. Enforce strong authentication, example multi-factor authentication MFA, implement timely deprovisioning, revocation or modification, of access to data and enterprise-owned assets. Regularly review user entitlements. Ensure that identities are unique and traceable to an individual, credentials are securely stored, and strong passwords are enforced. Restrict access to audit tools to prevent tampering or inappropriate disclosure of log data. Implement appropriate measures and compensating controls prior to provisioning third-party access. The CCM Identity and Access Management domain aligns with the recommendations and guidelines included in Domain 12, Identity, Entitlement, and Access Management, of the Guidance 196 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 196. HRS 10 User Responsibility HRS 11 Workspace March 4, 10 Identity and Access Management Cloud computing heavily impacts identity and access management as a security domain, mainly due to the increased complexity and increased exposure of the cloud computing model. EKM03 Sensitive Data Protection EKM04 Storage and Access 3.4.9 Human Resources Security The human factor is a key element in the development, implementation, provisioning and management of technology. Human resource, HR, management has to do with the rules, practices, and actions that aid employees in effectively and efficiently participating in enterprise activities. Human resource management is about establishing, documenting, communicating, implementing, enforcing and maintaining policies, procedures, and tools. Human resource security is a key area in cybersecurity management, and in cloud security in particular. It has consistently been a factor in data breach reports 197, 19815, and in the CSA top threats reports. 199-16 risk associated with the human factor relate to both malicious actions and employee errors due to lack of skill, expertise, or awareness. Awareness. Following are examples of the measures the HR department should implement, introduce provisions for adherence to established information governance and security policies. Assign, document and communicate the roles and responsibilities of employees, contractors, and third-party users, example through a RACI matrix. Create procedures to determine how and when enterprise-owned assets are to be returned upon contract termination. Introduce policies, procedures, and technical measures to manage risks associated with permitting mobile device access to corporate resources, example bring your own device, BYOD, policy. Enforce non-disclosure/confidentiality agreements. Establish and execute a security awareness training program for all contractors, third-party users, and employees. Make personnel aware of their roles and responsibilities for maintaining awareness and compliance with established established policies and procedures, and applicable legal, statutory or regulatory compliance obligations. These controls apply both from the perspective of the CSP and the cloud customer. The controls included in the CCM Human Resources Security domain do not have a direct corresponding domain in the guidance. Following are the controls: HRS-01 Asset Returns, HRS-02 Background Screening, HRS-03 Employment Agreements, HRS-04 Employment Termination, HRS-05 Mobile Device Management, HRS-06 Non-Disclosure Agreements, HRS-07 Roles/Responsibilities, HRS-08 Technology Acceptable Use, HRS-09 Training/Awareness. 15198 Verizon, 2018 Data Breach Investigations Report, https://enterprise.verizon.com/resources/reports/dber_2018_report.pdf 16199 OPSI Cloud Security Alliance. HRS-10 User Responsibility, HRS-11 Workspace. March 4, 10 Identity and Access Management. Cloud computing heavily impacts identity and access management as a security domain, mainly due to the increased complexity and increased exposure of the cloud computing model. The increased complexity results from the cloud imposing shared responsibilities, collaboration, and trusted relationships between multiple parties, i.e., between the IaaS, PaaS, and SaaS providers, the end users, and the identity providers. Such complex relationships are further complicated by the fact that very often an organization uses hundreds, if not thousands, of different services. The increased exposure risk is related to the very nature of the cloud. The accessibility of services through the internet dramatically increases the risks of credential theft, impersonification, and account takeover. For example, to properly implement IAM controls, an organization needs to map identities, such as a person, a device, an application, any other software, a virtual machine, to some attributes, example the role within the company, the location of a server, the function of a piece of code. It is then necessary to define the right privileges associated with the identities. The risks associated with IAM are that all of this takes place within a complex supply chain that includes several third parties that are not under the direct control of the organization, possibly using different systems and technologies. An identity mapping exercise would need to be coordinated within a defined service architecture that adopts identity federation by leveraging the right frameworks. Other factors further complicating the IAM approach: management of privileged users, management of third parties' employee-owned devices. Due to BYOD policies, following are examples of measures an organization should have in place in order to mitigate the risks related to IAM: establish, implement, enforce, and maintain policies and procedures to manage information about the identities of who accesses data and enterprise-owned assets, and to determine their level of access. Review and update policies and procedures regularly. Enforce an authorization process based on the principles of least privilege and segregation of duties. Enforce strong authentication, example multi-factor authentication MFA, implement timely deprovisioning, revocation or modification, of access to data and enterprise-owned assets. Regularly review user entitlements. Ensure that identities are unique and traceable to an individual, credentials are securely stored, and strong passwords are enforced. Restrict access to audit tools to prevent tampering or inappropriate disclosure of log data. Implement appropriate measures and compensating controls prior to provisioning third-party access. The CCM Identity and Access Management domain aligns with the recommendations and guidelines included in Domain 12, Identity, Entitlement, and Access Management, of the Guidance. 196 Certificate of Cloud Auditing Knowledge Study Guide, Copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 196. Following are the controls: IAM-01 Audit Tools Access, IAM-02 Credential Lifecycle/Provision Management, IAM-03 Diagnostic/Configuration Ports Access, IAM-04 Policies and Procedures, IAM-05 Segregation of Duties, IAM-06 Source Code Access Restriction, IAM-07 Third-Party Access, IAM-08 Trusted Sources, IAM-09 User Access Authorization, IAM-10 User Access Reviews, IAM-11 User Access Revocation, IAM-12 User ID Credentials, IAM-13 Utility Programs Access. March 4, 11 Infrastructure and Virtualization. This CCM domain covers two fundamental pieces of cloud computing: the infrastructure and the virtualization technologies. The infrastructure is essentially the compute, storage, and network physical layers, while the virtualization technologies are what allow the abstraction of the logical from the physical domain. Virtualization is one of the key elements of IaaS cloud offerings and private clouds, and it is likely to be used in portions of the backend of PaaS and SaaS providers as well. Virtualization is, naturally, a key technology for virtual desktops, which are delivered from private or public clouds. When addressing infrastructure and virtualization security in cloud computing, it is important to clearly understand the delineation of responsibilities based on the shared responsibility model and to determine what the CSP and customer should handle, respectively. In general terms, the IaaS provider is in charge of the security of the virtualization infrastructure, example physical security measures, network segregations, ensuring isolation, hardening the hypervisor. The cloud customer is responsible for the security of the workloads, such as virtual machines or containers, the virtual network, images, security settings, example managing access to the cloud management plane, logging and monitoring, and more. The cloud customer could be a PaaS or SaaS provider, i.e., any organization building upon the IaaS infrastructure. Cloud infrastructures are rapidly evolving, and new concepts and technologies, such as serverless, are being adopted. Serverless technologies have redefined the attribution of the security responsibilities between IaaS and PaaS and SaaS, and between the CSP and customer. Following are examples of measures an organization should have in place to mitigate the risk related to infrastructure and virtualization management. Establish, implement, enforce, and maintain policies and procedures to ensure the security, retention and access control of audit logs. Continuously monitor security audit logs to detect anomalies, and take appropriate action. Monitor, encrypt, and restrict communications between environments to authenticated and authorized connections. 197 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 197. Document allowed services, protocols, and ports. Harden the host and guest OS, hypervisor, or infrastructure control plane. Design, develop, deploy and configure multi-tenant applications, infrastructure system, and network components to ensure segmentation and segregation. Restrict access to network environments to authorized personnel. Provide segmentation, monitoring/detection and policy enforcement capabilities within the network architecture. Implement defense in-depth techniques for detection and timely response to network-based attacks. The CCM infrastructure and virtualization domain aligns with the recommendations and guidelines included in domains 7 and 8, infrastructure security and virtualization and containers, of the guidance. Following are the controls: IVs 01 intrusion detection, IVs 02 change detection, IVs 03 clock synchronization, IVs 04 information security documentation, IVs 05 vulnerability management, IVs 06 network security, IVs 07 OS hardening and base controls, IVs 08 production/non-production environments, IVs 09 segmentation, IVs 10 VM security vMotion data protection, IVs 11 VMM security hypervisor hardening, IVs 12 wireless security, IVs 13 network architecture March 4, 12 interoperability and portability. Interoperability is the requirement that a processing system's components work together to achieve their intended result. It should be possible for the system to continue to work if components are replaced with new or different components from other providers. Portability provides for application and data components to continue to work the same way when moved from one cloud environment to another without having to be changed. Portability is achieved by removing dependencies on the underlying environment. A portable component can be moved easily and reused regardless of the provider, platform, operating system, location, storage, or other elements of the surrounding environment. Portability and interoperability considerations are not unique to cloud environments, and their related security aspects are not new concepts resulting from cloud computing. However, the open and often shared processing environments that exist within the cloud require even greater precautions than traditional processing models. Multi-tenancy means that data and applications reside with data and applications of other companies, and that access to confidential data, intended or unintended, is possible through shared platforms, shared storage, and shared networks. Guidance v3. Lack of interoperability and portability can expose both cloud customers and CSPs to a variety of risks and considerably reduce the benefits of cloud computing. Among those risks, 198 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 198. Application, vendor, or provider lock-in. Choosing a particular cloud solution may restrict the customer's ability to move to another cloud offering or CSP. Processing incompatibility and conflicts causing service disruption. The provider, platform, or application differences may expose incompatibilities that cause applications to malfunction within a different cloud infrastructure. Unexpected application re-engineering or business process changes. Moving to a new cloud provider can introduce the need to rework the way a process functions or require coding changes to retain original behaviors. Costly data migration or data conversion. Lack of interoperable and portable formats may lead to unplanned data changes when a customer moves to a new provider. Retraining or retooling new applications or management software may be required. Loss of data or application security. Differences in security policy, control, key management, or data protection between providers may open undiscovered security gaps when a customer moves from one provider or platform to another. Lack of compliance. Moving to a new provider may result in conflicts with application laws and regulations. Following are examples of measures that an organization should have in place to mitigate the risks related to the lack of interoperability and portability. Make published APIs securely available. Establish policies and procedures and define the terms of information processing, interoperability and portability for application development. Implement standardized network protocols for the import and export of data. Implement standardized network protocols for the management of all interoperability and portability systems. Document relevant interoperability and portability standards in use. Use an industry-recognized virtualization platform and standard virtualization formats. The controls included in the CCM interoperability and portability domain do not have a dedicated corresponding domain in the guidance v4, but they do in v3, domain 6, interoperability and portability. Following are the controls: IPY01 APIs, IPY02 data request, IPY03 policy and legal, IPY04 standardized network protocols, IPY05 virtualization. March 4, 13 Mobile security. Mobile computing is a broad term that can define any means of using a computer while outside the corporate office, including working from home, or from an airport or hotel while on the road. The means to perform mobile computing can include kiosks to remotely connect to the corporate office, home computers, laptops, tablets, or smartphones. Specialized or integrated devices could also be considered mobile computing devices. The CCM mobile security domain focuses on implementing controls to mitigate the risks associated with module devices and endpoint devices in general. Internet of Things, IoT, technologies are not in the scope of this domain. 199 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 199. The risk with mobile and endpoint security mainly relate to user behavior, and the awareness, or lack, of a company's approach to acceptable use of devices and technologies. Example: managed versus unmanaged, enterprise-owned versus personal. Following are examples of measures an organization should take to mitigate the risks related to mobile and endpoint devices. Maintain an inventory of all managed and unmanaged endpoints used to store and access company data. Deploy centralized solutions to manage and technically enforce policies and controls for all endpoints. Manage changes to endpoint operating systems and patch levels through the organization's change management processes. Encrypt endpoints that are permitted to store company information to prevent unauthorized access to data in case the endpoint is lost, stolen, or disposed of improperly. Establish, implement, enforce, and maintain policies and procedures to define the acceptable use policy requirements, differentiating between managed and unmanaged endpoints. A list of the approved systems, servers, applications, application stores, application extensions, and plugins. Prohibition of the installation of non-approved applications. Prohibition of the circumvention of vendor-supported and integrated, built-in, security controls on endpoints, i.e., jailbreaking or rooting. Privacy requirements for remote location identification, litigation, e-discovery, and legal holds, especially for personally owned devices. The controls included in the CCM mobile security domain do not have a dedicated corresponding domain in the guidance. Following are the controls: MOS 01 anti-malware, MOS 02 application stores, MOS 03 approved applications, MOS 04 approved software for BYOD, MOS 05 awareness and training, MOS 06 cloud-based services, MOS 07 compatibility, MOS 08 device eligibility, MOS 09 device inventory, MOS 10 device management, MOS 11 encryption, MOS 12 jailbreaking and rooting, MOS 13 legal, MOS 14 lockout, MOS 15 operating systems, MOS 16 passwords, MOS 17 policy, MOS 18 remote wipe. 200 certificate of Cloud Auditing Knowledge Study Guide, copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 200. MOS 19 Security Patches, MOS 20 Users, March 4, 14 Security Incident Management, e-discovery, and Cloud Forensics. An incident response plan is necessary for rapidly detecting incidents, minimizing loss and destruction, mitigating weaknesses exploited and restoring IT services. 218 Numerous best practices and standards exist for incident management, handling/response, such as NIST 861 Rev 2, ISO/IEC 27035 and the ANSYS strategies for incident response and cyber crisis cooperation. The CCM takes these into account and aims to provide additional support specific to cloud computing. The cloud computing environment imposes some changes compared to implementing an incident response plan in an on-premises scenario. This is mainly due to the need to determine and coordinate the actions of the CSP and the cloud customers. From a cloud customer perspective, incident response might become challenging if contracts and SLAs do not sufficiently clarify the roles and responsibilities of the parties, or if the communication and escalation processes, which are key in an effective incident response plan, lack specific direction on whom to contact and how in the event of a security event or incident. Cloud forensics is the application of science to the identification, examination, collection, and analysis of data while preserving the information and maintaining a strict chain of custody for the data in cloud computing, as a subset of network forensics. Electronic discovery, e-discovery or e-discovery, refers to any process in which electronic data is sought, located, secured, and searched with the intent of using it as evidence in a civil or criminal legal case. Forensics has to be carried out in a highly dynamic environment, which challenges basic forensic necessities such as establishing the scope of an incident, the collection and attribution of data, preserving the semantic integrity of the data, and maintaining the stability of evidence overall. These problems are exacerbated when cloud customers attempt to carry out forensic activities, since they operate in a non-transparent environment, which underscores the necessity of CSP support. Following are examples of measures an organization should have in place to mitigate the risks related to incident management, e-discovery, and forensics. Establish, document, implement, enforce and maintain security incident response plans. Incident response plans must be subject to testing for effectiveness at planned intervals or upon significant organizational or environmental changes. Ensure that incident response plans involve relevant internal departments, impacted customers, and other business relationships that represent critical intra-supply chain business process dependencies. Maintain points of contact for applicable regulation authorities, law enforcement, and other legal jurisdictional authorities to ensure that direct compliance liaisons have been established and to be prepared for a forensic investigation. Establish, implement, enforce, and maintain policies and procedures and supporting business processes and technical measures to triage security-related events and ensure timely and thorough incident management. Inform personnel and third parties of their responsibilities, and instruct them to report all information security events in a timely manner and through predefined communications channels. Establish, implement, enforce, and maintain forensic procedures, including chain of custody. 18200 Ccak, P. T. Miller, T. Grants, K. Scarfone, Computer Security Incident Handling Guide, National Institute of Standards and Technology, August 2012, https://nlopubs.nist.gov/nistpubs/special publications/nist.sp.800-61r2.pdf 201 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 201. Implement mechanisms to monitor and quantify the types, volumes, and costs of information security incidents. The CCM Security Incident Management, e-discovery, and Cloud Forensics domain aligns with the recommendation and guidelines included in domains 3 and 9, legal issues, contracts, and electronic discovery and incident response, of the guidance. Following are the controls: SEF01 Contact/Authority Maintenance, SEF02 Incident Management, SEF03 Incident Reporting, SEF04 Incident Response, Legal Preparation, SEF05 Incident Response Metrics, March 4, 15 Supply Chain Management, Transparency and Accountability. Supply Chain Management, Transparency and Accountability address the need for ensuring a CSP takes due care in managing its supply chain and the risks associated with governing data within the cloud. This domain is critical, because it deals with some of the core issues of cloud computing, such as the non-transferability of accountability, the need for transparency, and the impact of the cloud on security assessment, penetration testing, and auditing. Supply chain agreements, example SLAs, between providers and customers should incorporate provisions or terms for the following: scope of business relationship and services offered, example customer data acquisition, exchange, and usage, features and functionality, roles and responsibilities of provider and customer, subcontracted or outsourced business relationships, physical geographical location of hosted services, and any known regulatory compliance considerations, primary points of contact. For the duration of the business relationship, references to detailed supporting and relevant business processes and technical measures implemented to enable effective governance, risk management, assurance, and legal, statutory and regulatory compliance obligations associated with all affected business relationships. Notification and requisite pre-authorization of any changes controlled by the provider with customer, tenant, impacts timely notification of a security incident, or confirmed breach, to all customers, tenants, and other business relationships impacted, i.e., upstream and downstream impacted supply chain, assessment and independent verification of compliance with agreement provisions and terms, example industry acceptable certification, attestation audit report or equivalent forms of assurance, without posing an unacceptable business risk of exposure to the organization being assessed, expiration of the business relationship and treatment of customer, tenant, data. Impacted customer service-to-service application, API, and data interoperability and portability requirements for application development and information exchange, usage, and integrity persistence. It is critical that CSPs clearly delineate shared responsibility model, control applicability, and ownership for each control for their specific service model and offering, including which controls have customer security responsibilities, in whole or in part. They should clearly and completely describe those responsibilities. For the customers, it is important to review and validate the CSP's shared responsibility model documentation. Both parties must implement and operate their instances of the service accordingly. 202 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 3, Introducing CCM and CAIQ. Image with the following description, image for page with label 202. The controls included in the CCM supply chain management, transparency, and accountability domain do not have a dedicated corresponding domain in the guidance. Following are the controls: STA01 Data Quality and Integrity, STA02 Incident Reporting, STA03 Network/Infrastructure Services, STA04 Provider Internal Assessments, STA05 Supply Chain Agreements, STA06 Supply Chain Governance Reviews, STA07 Supply Chain Metrics, STA08 Third-Party Assessment, STA09 Third-Party Audits. March 4, 16 Threat and Vulnerability Management. Threat and vulnerability management programs provide a way to assess the potential business impact and likelihood of threats and risk to the organization information infrastructure before events occur. 20119 Following are examples of measures that an organization should include in its threat and vulnerabilities management program: establish, implement, enforce, and maintain policies, procedures, and technical measures to prevent the execution of malware on enterprise-owned or managed assets. Implement technical measures and supporting processes for vulnerabilities detection and use a risk-based model for prioritizing the remediation of identified vulnerabilities. Implement a process for tracking and reporting vulnerability identification and remediation activities. Provide a summary of identified weaknesses to stakeholders if the system owner shares responsibility for the remediation, and inform them of the policies and procedures for threat and vulnerability management. Update detection tools, threat signatures, and indicators of compromise. Perform periodic penetration testing. Establish metrics for vulnerability identification and remediation at defined intervals. The controls included in the CCM threat and vulnerability management domain do not have a dedicated corresponding domain in the guidance. Following are the controls: TVM01 Antivirus/Malicious Software, TVM02 Vulnerability/Patch Management, TVM03 Mobile Code 19201 DILD, T, Enterprise Vulnerability Management, Ccak Registered Journal, March 31, 2017, www.icaka.org/resources/icaka-journal/issues/2017/volume-2/Enterprise Vulnerability Management. 203 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. Chapter 3, Introducing CCM and CAIQ. Image with the following description, image for page with label 203. March 4, 17 Governance and Risk Management. Corporate governance is the set of processes, technologies, customs, policies, laws and institutions affecting the way an enterprise is directed, administered, or controlled. It also includes the relationship among the many stakeholders involved and the goals of the company. Information risk management is the process of identifying and understanding exposure to risk and the capability of managing it, aligned with the data owner's risk appetite and tolerance. An effective governance and enterprise risk management cloud computing program flows from well-developed information security governance processes as part of the organization overall corporate governance obligations of due care. This CCM domain aligns with the recommendation and guidelines included in Domain 2, Governance and Enterprise Risk Management, of the guidance. See Chapter 1 on Cloud Governance for more details. Following are the controls: GRM01 Baseline Requirements, GRM02 Data Focus Risk Assessments, GRM03 Management Oversight, GRM04 Management Program, GRM05 Management Support/Involvement, GRM06 Policy, GRM07 Policy Enforcement, GRM08 Policy Impact on Risk Assessments, GRM09 Policy Reviews, GRM10 Risk Assessments, GRM11 Risk Management Framework. 3.5 The Consensus Assessment Initiative Questionnaire, CAIQ. This section describes the Consensus Assessment Initiative Questionnaire, CAIQ. 3.5.1 The CAIQ and why it was created. The Consensus Assessment Initiative Questionnaire, CAIQ, provides cloud customers and auditors with a set of questions they can ask a CSP about its security posture and adherence to the CSA best practices, CCM, and the guidance. The CAIQ was created as a companion document to support better adoption of the CCM. Where the CCM defines the control specification, the CAIQ defines questions to ensure implementation. The CAIQ consists of yes or no answers that can be expanded on with explanatory text in a dedicated notes column. This allows a CSP to provide additional information that a potential customer can use to better evaluate how a control has been implemented. It also enables the provider to eventually offer a better explanation of the application of the shared responsibility model. Like the CCM, the CAIQ comes in a spreadsheet format with a structure that is identical to the Cloud Controls Matrix. 204 Certificate of Cloud Auditing Knowledge Study Guide, copyright 2021, Cloud Security Alliance and Ccak. All rights reserved. The relationship between a CCM control and a CAIQ question in most cases is many to one. This is by design, because the CCM is based on 133 controls, whereas the CAIQ has 310 questions in its latest version 3.1. Depending on the nature and the complexity of the CCM control, there can be one or several questions to ask to verify the implementation of a certain control. For example, the control AAC02 in the audit and assurance compliance domain, see Figure 3.3, includes numerous requirements. Therefore, more than one question is required to verify whether the CSP has implemented all the necessary requirements within that control. 3.5.2 CAIQ Target Audience, Purpose, and Differences from CCM. This section describes the CAIQ target audience, purpose and differences from CCM. Target audience. The CAIQ target audience includes cloud customers, CSPs, and auditors. Figure 3.3 Control AAC02 Example Control Group Audit Assurance and Compliance Audit Planning Audit Assurance and Compliance Independent Audits AAC01 AAC02 AAC02.1 AAC02.2 AAC02.3 AAC02.4 AAC01.1 Control Specification Consensus Assessment Questions CGID SIT Audit plans shall be developed and maintained to address business process disruptions. Auditing plans shall focus on reviewing the effectiveness of the implementation of security operations. All audit activities must be agreed upon prior to executing any audits. Independent reviews and assessments shall be performed at least annually to ensure that the organization addresses nonconformities of established policies, standards, procedures, and compliance obligations. Do you allow tenants to view your SOC 2/ISO 27001 or similar third-party audit or certification reports? Do you conduct network penetration tests of your cloud service infrastructure regularly as prescribed by industry best practices and guidance? Do you conduct application penetration tests of your cloud infrastructure regularly as prescribed by industry best practices and guidance? Do you conduct internal audits regularly as prescribed by industry best practices and guidance? Do you produce audit assertions using a structured, industry-accepted format? Example Cloud Audit /A6 URI Ontology, Cloud Trust, SCAP/CyBEX, GRC-XML, ISACA's Cloud Computing Management Audi/Assurance Program, etc. Consensus Assessments Initiative Questionnaire V3.0.1 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 205 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label. CAIQ for cloud customers. Customers can use the standard set of questions in the CAIQ to verify that a CSP meets their security specifications. Cloud customers can use the CAIQ as a tool throughout various stages of the cloud lifecycle. During the pre-vetting of a CSP, before entering into an agreement, customers can use the CAIQ to compare provider security and privacy features with its own internal requirements. Once the service is up and running, customers can use the CAIQ to monitor if the security controls objectives are met over time. CAIQ for CSPs. CSPs use the CAIQ for two purposes: generate and provide controls and risk models, like the CCM, and generate a template questionnaire that is distributed to cloud customers. Service providers receive many customer requests for personalized questionnaires. This creates a significant workload, which is why CSPs started using CAIQ as a way to streamline their approach to customer requests. Now, instead of filling out hundreds, or even thousands, of customer requests, they get ahead by filling out one standard questionnaire and sending it to all their customers. Figure 3.4 CSA Star Registry Example Audit Assurance and Compliance Independent Audits AAC02 AAC02.1 Independent reviews and assessments shall be performed at least annually to ensure that the organization addresses nonconformities of established policies, standards, procedures, and compliance obligations. Do you allow tenants to view your SOC 2/ISO 27001 or similar third-party audit or certification reports? Yes, ISO 27001 certifications for XYZ and Co. Plus I can be found on the XYZ Trust portal at https://servicetrust.xyz.com/. Customers can also review SOC, ISO, PCI, and other audit reports. Additional audit information is available under NDA upon request by prospective and existing customers through their XYZ account representative. AAC02.2 Do you conduct network penetration tests of your cloud service infrastructure at least annually? Yes, as defined in ACE 01.1, regular scans are conducted, at least quarterly, against the Azure infrastructure and applications using a variety of commercial and proprietary scanning tools. Critical and hi-fi endings detected are reviewed and patched per the change and release management policy. Rescans are conducted within 30 days. Assume breach employs red team/blue team exercises, live site penetration testing and centralized security logging and monitoring to identify and address potential gaps, test security response plans, reduce exposure to attack, and reduce access from a compromised system, with periodic post-breach assessment and clean state restoration. AAC02.3 Do you conduct application penetration tests of your cloud infrastructure regularly as prescribed by industry best practices and guidance? Yes, scans are performed by Co plus I security professionals on behalf of XYZ. Penetration testing methodologies for infrastructure and application are defined and are based on a combination of common criteria, NIST SP 800-115, ETSI, OWASP, IETF and ISO 27000. To protect XYZ platform services, XYZ provides a distributed denial of service 207 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 207. The example considers three questions from the AAC domain AAC02.1, AAC02.2 and AAC02.3. The CSP offers several additional details that provide the customer better visibility into the CSP practices. It also provides the auditor with better data for the evidence collection process. Using CAIQ, an organization can build a robust RFP, request for proposal, and verify that the answers the CSP gives during the RFP interview are valid. Even so, it is always a good idea to perform due diligence if required, as it is easy for a respondent to check boxes. Whether the CSP is following through with the implementation should be confirmed. Differences between CCM and CAIQ. The CCM and CAIQ help provide a solid foundation for assessing the risk models and controls of a cloud provider, but there are some differences between the two tools. Figure 3.5. Figure 3.4 CSA Star Registry Example, DDoS, defense system that is part of XYZ's continuous monitoring process, and is continually improved through scheduled penetration testing and red team exercises. The XYZ DDoS defense system is designed to mitigate attacks from the outside and also from other XYZ tenants. The XYZ DDoS defense technology provides detection and mitigation techniques such as SYN cookies, rate limiting and connection limits to help ensure that such attack do not impact the customer environment. 208 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing The example considers 3 questions from the AAC domain AAC 02.1, AAC 02.2 and AAC 02.3. The CSP offers several additional details that provide the customer better visibility into the CSP practices. It also provides the auditor with better data for the evidence collection process. Using CAIQ, an organization can build a robust RFP, request for proposal, and verify that the answers the CSP gives during the RFP interview are valid. Even so, it is always a good idea to perform due diligence if required, as it is easy for a respondent to check boxes. Whether the CSP is following through with the implementation should be confirmed. Differences between CCM and CAIQ. The CCM and CAIQ help provide a solid foundation for assessing the risk models and controls of a cloud provider, but there are some differences between the two tools. Figure 3.5. Figure 3.4 CSA Star Registry Example, DDoS, defense system that is part of XYZ's continuous monitoring process, and is continually improved through scheduled penetration testing and red team exercises. The XYZ DDoS defense system is designed to mitigate attacks from the outside and also from other XYZ tenants. The XYZ DDoS defense technology provides detection and mitigation techniques such as SYN cookies, rate limiting and connection limits to help ensure that such attack do not impact the customer environment. 208 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. 3.6 CCM and CAIQ Structure. This section describes the CCM and CAIQ structure. 3.6.1 CCM Structure. The CCM v 3.0.1 is structured with 16 security domains and 133 controls. Control domains. Domains are color-coded in the spreadsheet for easy identification. Figure 3.6. Under each domain, such as application and interface security, business continuity, encryption, and key management, there are several controls that can be selected for implementation depending on the environment, or for auditing cloud providers. Figure 3.5 Comparison of CCM and CAIQ provides a controls framework to give a detailed understanding of security concepts and principles that are aligned to the guidance domains. Assesses the overall security of a CSP service. Covers 16 domains. Includes 133 controls. Specifies overall security needs of cloud consumers. Assesses the overall security risk of a cloud provider. Provides industry accepted ways to document which security controls exist in IaaS, PaaS, and SaaS offerings. Assesses presence of controls of a CSP service. Includes 310 questions. Covers 133 controls. A cloud consumer and cloud auditor may wish to review a CSP to gauge the CSP's security and conduct initial assessment followed by further clarifying questions. Source: Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 209 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description. Image for page with label 209. CCM columns. Figure 3.7 shows the CCM controls matrix. Control domain and ID column. Figure 3.8 shows the CCM control domain and ID column. Figure 3.6 CCM security domains. ACE application and interface security. AAC audit assurance and compliance. BCR business continuity management and op resilience. CCC change control and configuration management. DSI data security and information lifecycle management. DCS data center security. EKM encryption and key management. GRM governance and risk management. HRS human resources security. IAM identity and access management. IVs infrastructure and virtualization. IPY interoperability and portability. MOS mobile security. SEF secretary incident Management, eDisk and Cloud Forensics STA Supply Chain Management, Transparency and Accountability TVM Threat and Vulnerability Management Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group Figure 3.7 Cloud Controls Matrix Control Domain CCM 3.0 Control ID Updated Control Specification Architectural Relevance Cloud Service Delivery Model Applicability Supplier Relationship Scope Applicability Corp Gov Relevance Physics SaaS Service Provider Tenant / Consumer ISO / IEC 27001 to 2013 NISSP 800-53. R4 App JPOS IaaS Network Computer Storage App Data Cloud Controls Matrix Application and Interface Security Customer Access Requirements ACE02 Prior to granting customers access to data, assets, and information systems, security, contractual, and regulatory requirements for customer access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXX Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 210 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 210. Control domain. The domain defines which category the controls fall under. Each domain is assigned an acronym. For example, the application and interface security domain is assigned the acronym ACE. Control ID. There may be one or several controls under a domain. Each control has a control ID, which is the domain acronym followed by a number. For example, ACE02 means second control in the application and interface security domain. Another example is IAM03. This means third control in the identity and access management domain. Control specification and architectural relevance. The control specification column describes the purpose of the control. Figure 3.9. Figure 3.8 Control domain and ID column. Example control domain CCM 3.0 Control ID application and interface security customer access requirements ACE02 Example control domain is application and interface security. ACE02 means second control in application and interface security domain. The second control of ACE is customer requirements. 1-2 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 211 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 211. Architectural relevance. The CCM has 6 columns for architectural relevance, which includes applicability to the physical infrastructure, network, compute, storage, applications, data, or all of these areas. Applicability of architectural relevance to the corresponding control is marked with an X in the column. Columns can be used for filtering, i.e., all storage elements. Depending on the description in the control specification, the volunteers at CSA determined where a control is applicable. Does it apply to physical infrastructure, applications, data, or does it apply to all these areas? Because customer access needs to be considered for all these areas, there is an X in all these columns. Some controls apply only to specific areas. For example, security of e-commerce data that traverses public networks will need to be appropriately classified and protected from fraudulent activity, unauthorized disclosure, or modification in such a manner to prevent contract dispute and compromised data. This control is applicable only to network and data, as the other areas, like storage and physical infrastructure, are not directly affected by this control. Corporate governance relevance. Corporate governance relevance, figure 3.10 determines whether the control is relevant to corporate governance. Controls that are relevant to corporate governance are marked with an X. Figure 3.9 Control specification and architectural relevance. Example updated control specification architectural relevance cloud service delivery model applicability supplier relationship scope applicability corp gov relevance physics SaaS service provider tenant / consumer ISO / IEC 27001 to 2013 NISSP 800-53 R4 App JPOS IaaS Network Computer Storage App Data prior to granting customers access to data, assets, and information systems, security, contractual, and regulatory requirements for customer access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXX Cloud Service Del Ivory Mod LAPPL ICAP ILITY Supplier Relationship Scope Applicability Corp Gov Relevance SaaS Service CEPRO Vidier Tenant / Consum ER ISO / IEC 27001 201 NISSP 800-53 R4 App JPOS IaaS. 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXX Control Specification ACE02 Purpose Definition establishes when to give access. 1. Architectural relevance includes all 6 elements. 2. Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 212 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 212. As defined in Chapter 1, corporate governance is the set of processes, customs, policies, laws and institutions affecting the way an enterprise is directed, administered, or controlled. Corporate governance includes the relationship among the many stakeholders involved in the goals of the company. Good governance is based on the acceptance of the rights of shareholders, as the true owners of the corporation, and the role of senior management as trustees. Cloud Service Delivery Model Applicability. Cloud Service Delivery Model Applicability, Figure 3.11, determines which service model controls are applicable to IaaS, PaaS or SaaS. Figure 3.10 Corporate Governance Relevance Updated Control Specification Architectural Relevance Cloud Service Delivery Model Applicability Supplier Relationship Scope Applicability Corp Gov Relevance Physics SaaS Service Provider Tenant / Consumer ISO / IEC 27001 to 2013 NISSP 800-53R4 App J PaaS IaaS Network Computer Storage App Data prior to granting customers access to data, assets, and information systems, security, contractual, and regulatory requirements for customer access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXX Updated Control Specification Architectural Relevance Cloud Service Del Ivory Mod L Applicability Supplier Relationship Scope Applicability Y Physical SaaS Service CE Provider Tenant / Consumer ISO / IEC 27001 201-3 NISSP 800-53R4 APPJ PaaS IaaS Network Computer Storage EAPP Data PRI or to granting customers access to data, assets, and INF formation systems, security Y, contractual, and regulatory requirements F or custom R access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXXACE02 Customer access requirements have corporate governance implications. Source: Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 213 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 213. This column explains which model a control applies to IaaS, PaaS, or SaaS. For example, this would be applicable if a cloud customer wanted to assess a cloud provider to determine if it wanted to use its IaaS service. Microsoft, for example, has used the CCM to address security concerns for some of its products, such as Azure, Microsoft Dynamics 365, and Office 365. A customer seeking to assess an Azure deployment for its IaaS environment would look at the X mark in the IaaS column to identify which controls apply, and based on that could assess the security of Microsoft's IaaS services. Supplier relationship. The supplier relationship, Figure 3.12 determines the applicability of the controls to the provider or the tenant. Applicability of supplier relationship to the corresponding control is marked with an X in the column. Figure 3.11 Cloud Service Delivery Model Applicability Updated Control Specification Architectural Relevance Cloud Service Delivery Model Applicability Supplier Relationship Scope Applicability Corp Gov Relevance Physics SaaS Service Provider Tenant / Consumer ISO / IEC 27001 to 2013 NISSP 800-53R4 App J PaaS IaaS Network Computer Storage App Data prior to granting customers access to data, assets, and information systems, security, contractual, and regulatory requirements for customer access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXX Updated Control Specification Architectural Relevance Supplier Relationship Scope Applicability Y Corp Gov Rel Evan CE Physics Service PRO Provider Tenant / Consum ER ISO / IEC 27001 213 NISSP 800-53R4 App J Network Compute R Storage EAPP Data prior to granting customers access to data, assets, and INF formation systems, security Y, contractual, and regulator Y requirements F or custom R access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXXACE02 applies to all three delivery models. Source: Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 214 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 214. This column determines the supplier relationship. For example, controls related to business continuity and management of the data center are applicable to the provider and not the tenant. There is an X in the supplier cell and the tenant cell will be blank. This column helps in the adoption of the shared responsibility model, because it makes clear who is responsible for which controls, in terms of design, implementation, testing, and management. Scope applicability, Figure 3.13 maps existing industry frameworks to controls in the 16 domains. Mappings leverage the work done with other standards, regulations, and control frameworks. Figure 3.12 Supplier Relationship Updated Control Specification Architectural Relevance Cloud Service Delivery Model Applicability Supplier Relationship Scope Applicability Corp Gov Relevance Physics SaaS Service Provider Tenant / Consumer ISO / IEC 27001 to 2013 NISSP 800-53R4 App J PaaS IaaS Network Computer Storage App Data prior to granting customers access to data, assets, and information systems, security, contractual, and regulatory requirements for customer access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXX Updated Control Specification Architectural Relevance CL UD Service Del Ivory Mod L Applicability Scope Applicability Corp Gov Rel Evan CE Physical SaaS ISO / IEC 27001 to 213 NISSP 800-53R4 App J PaaS IaaS Network Compute R Storage EAPP Data prior to granting customers access to data, assets, and information systems, security Y, contractual, and regulatory requirements F or custom R access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either general or in support of a specific program or information system need. XXXXXXXXXX Customer access requirements are applicable if evaluating a CSP or consumer. Source: Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 215 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 215. The last column in the CCM maps the existing industry frameworks to the controls of the 16 domains. This is one of the most useful features of the CCM, as it leverages the work done by existing standards, regulations, and control frameworks. Currently, the CCM controls are mapped to approximately 40 standards. As the previous example illustrates, the ISO standard is mapped using the section number A9.1.1. Some standards have the actual control mentioned, in this case NIST. For example, if the cloud provider being assessed is compliant with the NIST SP 800-53 standard, it probably already has measures in place to fulfill this requirement. 3.6.2 CAIQ Structure Figure 3.14 shows the Consensus Assessments Initiative Questionnaire, CAIQ, structure. Figure 3.13 Scope Applicability Updated Control Specification Architectural Relevance Cloud Service Delivery Model Applicability Supplier Relationship Scope Applicability Corp Gov Relevance Physics SaaS Service Provider Tenant Consumer ISO/IEC 27001 to 2013 NIS SP 800-53 R4 App J POS IaaS Network Computer Storage App Data prior to granting customers access to data, assets, and information systems, security, contractual, and regulatory requirements for customer access shall be addressed. A 9.1.1 AP1 The organization determines and documents the legal authority that permits the collection, use, maintenance, and sharing of personal identifiable information, PII, either generally or in support of a specific program or information system need. XXXXXXXXXXX Updated Control Specification Architectural Relevance Cloud Service Dell Ivory Mod LAPPL ICAP ILITY Supplier Relationship Corp Gov Relevance Physical SaaS Service CEPR Ovider Tenant /Consum ER SIaaS Network Compute R Storage EAPP Data prior to granting customers access to data, assets, and INF formation systems, secure it Y, contractual, and regulatory requirements F or custom R access shall be addressed DXXXXXXXXXXXX02 maps to ISO 27001 A 9.1.1 end. Has applicability to NIST 800 to 53 AP1. Source: Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 216 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 216. Control domain same as the control domain in CCM, color-coded to match to CCM v3.0.1, control ID a unique ID that identifies each control within a group or domain, same as the control ID in CCM v3.0.1, question ID the question ID for that control specification describes the purpose of the control, same as the control specification in CCM v3.0.1, consensus assessment questions corresponding to that control consensus assessment answers 3 options, yes, no and N/A. With explanations encouraged in each case notes for any additional information or comment in some cases, a question may not be applicable to a cloud provider. For example, if a cloud provider offers only POS services and uses another provider for its infrastructure needs, some data center control questions may not be applicable. Figure 3.14 CAIQ Structure Control Domain Application and Interface Security Application Security ACE01 ACE01.1 ACE01.2 ACE01.3 ACE01.4 ACE01.5 Control Specification Consensus Assessment Questions Consensus Assessment Answers Notes Yes No Not Applicable Control ID Question ID Applications and Programming Interfaces, APIs, shall be designed, developed, deployed, and tested in accordance with leading industry standards, example OWASP for web applications, and adhere to applicable legal, statutory, or regulatory compliance obligations. Do you use industry standards, i.e., OWASP Software Assurance Maturity Model, ISO 27034, to build security for your system/software development? Do you use an automated source code analysis tool to detect security defects in code prior to production? Do you use a manual source code analysis to detect security defects in code prior to production? Do you verify that all of your software suppliers adhere to industry standards for systems/software development lifecycle, SDLC, security? SOS only, do you review your applications for security vulnerabilities and address any issues prior? Consensus Assessments Initiative Questionnaire v3.1 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 217 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 217. 3.7 CCM Relationship with other frameworks, Mappings and Gap Analysis. This section describes the CCM relationship with other frameworks. 3.7.1 CCM Mapping Objective and Scope. One of the key features of the CCM is the mapping with other frameworks. Although CCM is cloud-specific, it is normally integrated into organizations where other frameworks are being used. Because of this, it is paramount to establish a link between the standards in use and the CCM. The main objective of the mapping process is to map the CCM's controls to other frameworks and identify a semantic equivalence between the mapped controls. Currently, the CCM is mapped against 35 different standards, best practices, laws, and regulations. Some of them are national requirements specific for the cloud. Others are generic information security or privacy regulations, international standards, and sector-specific best practices. Currently, CCM maps to the following standards: ISO/IEC 27001 to 2013, ISO/IEC 27002:2013, ISO/IEC 27017 to 2015, ISO/IEC 27018 to 2014, ICPA TSC 2017, ICPA TSC 2014, C5 BSI Germany Canada Pipe to COBIT 5.0, COBIT 4.1, COPPA CSA Enterprise Architecture CSA Guidance v3.0, ANISA IAF PCI DSS v3.0, PCI DSS v3.2, FedRAMP Security Controls, Final Release, January 2012, Low Impact Level FedRAMP Security Controls, Final Release, January 2012, Moderate Impact Level HITRUST CSFV 8.195/46/. EC, European Union Data Protection Directive FERPA GAPP, August 2009, HIPAA/High-Tech Act BITS Shared Assessments SIG v6.0 ITAR Jericho Forum Mexico, Federal Law on Protection of Personal Data 218 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 218. NERCCIP NIST SP 800 to 53R3 NIST SP 800 to 53R4 NCSM ODCAUM, PAR 2.0 SIS AWS Foundation v1.1 Shared Assessments 2017 AUP IEC 62443-3-3:2013 Given their global footprint, many CSPs are often required to comply with several of these standards at the same time. For instance, a provider willing to offer services to both the US federal government and the German federal government would need to satisfy the requirements of both FedRAMP and BSI C5. It is therefore useful to have a tool that creates a link between all the various standards, especially considering that frequently the requirements between these various standards overlap. Based on the results of an analysis conducted by CSA in the context of the European Commission-funded project EUSEC 203,202041, the controls included in CCM are able to satisfy more than 80% of the requirements included in ISO/IEC 27001, ISO/IEC 27017, ISO/IEC 27018, BSI C5, ANISA Minimum Security Measures for DSPs, ICPA TSC 2016, Francis SEC Number Cloud, and other national standards from Spain and Slovenia. If a company needed to implement each standard from scratch, it would go through considerable duplication of effort, which is an additional cost. Linking the CCM with other international standards and regulations streamlines security and compliance for providers and customers. Mappings are useful to guide organizations in adhering to new standards or regulations. Take the example of a CSP that would like to expand beyond its APAC and European operations to enter the US market. It might be useful, or even necessary, to show adherence to HIPAA and FedRAMP. In this situation, the CCM mapping becomes very useful to help understand how the organization's existing security program and internal control framework can be leveraged to satisfy the new requirements and bridge gaps where they exist. 3.7.2 Gap Analysis and Reverse Mappings. The CCM mapping approach has evolved over time. In the beginning, the mapping constituted a way to link a CCM control to one or several controls of a target standard. See Figure 3.15. 2203 OPCIT EUSEC 21204 OPCIT EUSEC, D1.2 Security and Privacy Requirements and Controls 219 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and ISACA. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 219. Such an approach provided a way to create a link between controls, but it did not specify a few other important details, including which portion of the CCM control was covered by which controls in the target framework in the case of one-to-many mapping. Were the multiple requirements included in the CCM control objectives entirely satisfied by the controls in the target framework? If gaps existed, where were those gaps? Another limitation was that the CCM mapping was unidirectional, i.e., it would indicate the connection between a CCM control and one or many controls in the target framework, but it would not provide the target framework perspective. Control 123 in Framework X corresponds to which CCM controls? Are there any gaps? To overcome these limitations, CSA introduced the concepts of reverse mapping and gap analysis in 2017. 3.7.3 Mapping Methodology. The CCM mapping methodology is composed of 3 phases. Preparation. This includes the initial preparatory actions, such as defining the scope and creating the execution. 1. Instructions, leadership, and work packages. Execution. During this phase, the actual work of mapping and gap analysis is conducted. The execution phase 2 includes completion of the controls mapping, gap identification and gap analysis. Figure 3.15 Evolution of CCM mapping approach. Early stage control domain interoperability and portability policy and legal IPY03 updated control specification ANISA IAF CCM v3.0 control ID HITRUST CSF v8.1 ISO/IEC 27002:2013 ISO/IEC 27017:2015 policies, procedures, and mutually agreed upon provisions and/or terms shall be established to satisfy customer, tenant, requirements for service-to-service application, API, and information processing interoperability, and portability for application development and information exchange, usage, and integrity persistence. June 4, 03, B, June 4, 08. A, June 4, 08. B, 6.06. A, 6.06. B, 6.06. C, 6.06. D, 6.06. E, 6.06. F, 05.K 6.1.16.1.312.6.1144.2.318.1.118.2.316.1.1.8.1.1 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 220 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 220. Peer review and publication. This is the closing phase, when the peer review of the final draft takes place. 3. According to the CSA research life cycle. 20,523. A more detailed explanation about CCM mapping methodology can be found in the CSA document Methodology for the Mapping of the Cloud Controls Matrix 20624 Mapping and Reverse Mapping. This section explains CCM mapping and reverse mapping. Mapping CCM is based to other target. Each control in the CCM is initially matched to controls in another framework to make an equivalency determination. This approach considers which CCM controls are associated with the control in other established frameworks, and to what degree they are equivalent to each other, thus estimating the extent of new efforts necessary to align to the CCM requirements when another framework is already in use. Figure 3.16. Example. An example use case is that of conducting a mapping and gap analysis exercise using CSA CCM as the base framework. CCM controls are positioned on the left side of the mapping tool, and BSI C5 as the target framework. C5 mapped controls are positioned on the right side of the mapping tool. In this mapping configuration, the C5 controls are mapped against each CCM control. The gap analysis shows C5 controls meeting CCM control requirements partially, fully, or not at all. 23205 Cloud Security Alliance, Research Lifecycle, https://cloudsecurityalliance.org/research/lifecycle 24206 Cloud Security Alliance, Methodology for the Mapping of the Cloud Controls Matrix, CCM, 2018, https://downloads.cloudsecurityaLliance.org/assets/research/cloud-matrix/CCM-mapping-methodology.pdf Figure 3.16 CCM Control Mapping Example Application and Interface Security Application Security ACE01 Control Domain CCM v3.0 Control ID Updated Control Specification Gap Identification, full, partial, or no gap, controls mapping gap analysis compensating controls applications and programming interfaces, APIs, shall be designed, developed, deployed, and tested in accordance with leading industry standards, example OWASP for web applications, and adhere to applicable legal, statutory or regulatory compliance obligations. No gap BAY01 Cloud Control Matrix v3.0.11 UP CDEGF23 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 221 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 221. Reverse mapping's other target as base to CCM. Conversely, a reverse mapping uses another framework as the initial base to find equivalent controls addressed in the CCM. In a reverse mapping exercise, each control in the candidate framework is accounted for in the CCM when possible. The base framework/starting point used in a reverse mapping exercise is the candidate framework. Besides the shift in perspective, all other processes such as the mapping processes, gap analysis and integration of new requirements remain the same. Figure 3.17. Example. An example use case is that of conducting a reverse mapping and gap analysis exercise using BSI C5 as the base framework. C5 controls are positioned on the left side of the mapping tool, and CSA CCM as the target framework. CCM mapped controls are positioned on the right side of the mapping tool. In this mapping configuration, the CCM controls are mapped against each C5 control. The gap analysis results in having the CCM controls meeting the C5 control requirements partially, fully, or not at all. Reporting gap identification and analysis. Gap summaries identify full gaps and partial gaps. Full gaps indicate there are no matching controls in the candidate framework. Partial gaps indicate one or more matching controls do exist in the candidate framework, but they do not fully cover the extent of the specific control as defined in the base framework. A complete gap analysis can help inform planning efforts when determining the suitability of extending existing compliance documentation to match another framework. For the purposes of the CCM, a gap analysis specifically lists and explains the gaps between controls in the CCM and another framework. Mapping process and completeness. The goal of the mapping process is to identify a semantic equivalence between CCM controls and those included in other frameworks. Elements that can be used to evaluate equivalence include identifying whether both controls have the following: matching domain names, matching security control names. Figure 3.17 CCM control mapping example, compliance controls catalog, C5, BSIC 5AM01 standard ID control gap identification, full, partial, or no gap, controls mapping gap analysis compensating controls asset management / asset inventory no gap DCS01 GRM02 MOS 09. The controls proposed fully cover the requirements of C5. Compliance Controls Catalog, C5, 1 of CDEGF23 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group 222 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 222. Matching security control requirements and keywords. In both the other framework and the CCM, each security-related keyword found in a control requirement of the other framework should be investigated to determine if a keyword of semantic equivalence exists in the CCM. Content matching between security controls identified in both frameworks. This approach considers content in a more thorough manner, and successful matches are not as easily identifiable as in the keyword search approach. Tip: a mapping that is semantically equivalent refers to a scenario in which two or more controls between different frameworks completely cover each other in terms of scope. These controls are said to be semantically equivalent to each other. Gap identification and analysis, no gap, partial gap, and full gap definitions depending on the scope and objective of the project. A gap identification and analysis might be conducted after the initial mapping for remaining items that were not considered equivalent. A gap identification is essentially an analysis of two or more frameworks that seeks to determine the level of semantic equivalence between frameworks. During the gap identification process, three potential outcomes are possible: no gap, partial gap, and full gap. Consider the following to identify which of those three scenarios applies. No gap for a specific CCM control and its requirements. There is an equivalent control or set of controls in the candidate framework that fully satisfies the requirements of a corresponding control in the CCM. Partial gap for a specific CCM control and its requirements. There is a control or set of controls in the candidate framework that do not fully satisfy the requirements of the corresponding control in the CCM. For the partial gap case to hold, there should be at least one control in the candidate framework that is of semantic equivalence to a requirement in the CCM control. The relevant controls in the candidate framework should then be cited in the work package. Full gap for a specific CCM control and its requirements. There is no control or set of controls in the candidate framework that is of semantic equivalence. Essentially, this means that the CCM control is completely unaddressed by any control in the candidate framework. The preceding examples describe an analysis of the gaps that a candidate framework has compared to the CCM. The same logic can be applied to determine whether the CCM has gaps compared with a candidate framework. See figures 3.18 and 3.19. 223 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 223. Figure 3.18 CCM Control Mapping Example, ISO 27002 A.11 Physical and Environmental Security A.11.1, Secure Areas Objective, to prevent unauthorized physical access, damage, and interference to the organization's information and information processing facilities. 11.1.1 DCS02 Yes Physical Security perimeters shall be defined and used to protect areas that contain either sensitive or critical information and information processing facilities. ID control description controls mapping. Are there any controls listed in column D? No equals full gap, yes equals no gap, or partial gap. Do controls listed in column D fully satisfy the requirements of the control listed in column A? Yes equals no gap, no equals partial gap. If partial gap exists, please comment on the semantic equivalence of the mapped controls. ISO 27002 1 of CDEGF23 Source, Cloud Security Alliance, Cloud Controls Matrix, CCM, Working Group Figure 3.19 CCM Key Terms and Definitions. Terms definitions. Candidate framework refers to any recognized set of evaluation criteria, example standard, regulation, or code of practice, whether international or local technology or industry-specific frameworks. Domain. A set of related security controls categorized into a specific topic. For example, the CSA Cloud Controls Matrix, CCM, topics relate to the 14 CSA domains. Full gap. A similar criterion, control, does not exist in the other framework. Gap analysis. The breakdown of additional indicators and efforts needed to bridge a control requirement from one framework to another. Mapping. CCM controls are individually referenced to a non-CCM framework. A mapping can be one-to-one or one-to-many. No gap. The relevant control requirement in one framework is fully equivalent to another framework. Partial gap. Controls in two frameworks are similar, but not fully equivalent. Reverse mapping. The same as mapping, except the starting point is a non-CCM candidate framework rather than the CCM. Semantic equivalence. When security controls between two frameworks are determined to share the same meaning, based on context, how they were written and categorized. Security controls. Technical or administrative safeguards or countermeasures to modify information security risk to an organization. 224 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 224. 3.8 Transition from CCM v3.0.1 to CCM v4 version 4, v4, of the CCM is expected to be released in late 2020. The current version 3, v3.0.1, was released in 2014 and a few minor updates were issued since then, including additional mappings with a new framework. In 2018 and 2019, CSA published the ISO addendum and the German BSIC 5 addendum, to provide users with a gap analysis and compensating controls between the CCM and ISO/IEC 27001, 27002, 27017 and 27018, and C5. The CCM, like any other cybersecurity control framework, is subject to obsolescence and needs a periodic major update in order to better reflect the evolution of cloud technology, its adoption strategies, changes in the guidance, new technologies related to the cloud, and changes in the threat landscape. As CSA went through the mappings with other frameworks, it realized that there were several recently published cloud frameworks that were adding controls specifications that were missing in the cloud controls matrix. There are also several technological gaps with the CCM that CSA wanted to close by including new control references. For example, CSA conducted substantial research work on container, microservices and serverless, which is not included in CCM v3.0.1. Thus, there was a substantial need for a major update from version 3 to version 4. One of the other reasons for moving to the fourth version was making the CCM controls more auditable. The CCM is the reference framework for the CSA STAR program. Over the past few years, auditors who have audited the implementation of CCM controls for this program have provided feedback. The lessons learned from these auditors are currently being used to increase the clarity of the language and make controls more precise and easier to audit. 3.8.1 Understanding the changes between v3 and v4. This section describes the changes from CCM version 3 to version 4. Domain structure for version 4. CSA wanted to avoid major changes in the CCM domain structure. There were multiple reasons for this choice. The current version 3.0.1 has a structure that is flexible enough to embrace the technical and organizational changes that have occurred in the cloud market in the past 6 years and should remain valid in the short to medium term, 3 to 5 years. In other words, the existing structure can be considered future-proof. The users of any framework, including CCM, appreciate continuity, and evolutionary approaches are typically preferred to a complete upheaval of the framework structure unless a more substantial change is required. CCM is the foundational framework of the CSA STAR program, and there is a need to ensure continuity and comparability from one version to the next. Lack of continuity between versions can shock the user and delay the adoption of the new version of the framework because adapting to the changes requires too much work. That said, there will be changes in the names of some domains. Domain name changes include, domain EKM, encryption and key management, will be renamed cryptography, encryption, and key management. The GRM domain, governance and risk management, will be renamed, governance, risk, and compliance. GRC, domain AAC, audit, assurance, and compliance, will be renamed ANA, auditing and assurance, and the compliance topic will be moved to the GRC domain. 225 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Domain Data Security and Information Lifecycle, DSI, will become Data Security and Privacy Lifecycle Management, DSP, and its scope extended from security only to security and privacy. The mobile security domain will have a more general scope and become Cloud Endpoint Security. Merging CCM and CAIQ. Until now, the CCM and CAIQ have been published as two separate research documents. In version 4, however, the CCM and CAIQ will be merged. The CAIQ will be an additional column in the CCM framework in order to help simplify the adoption. Implementation and Auditing Guidelines. The new version will include implementation and auditing guidance documents to facilitate the use of the CCM. The implementation guidelines provide suggestions, recommendations, and examples of how to implement the CCM controls. Given a certain control specification, the document will help explain what should be done to effectively implement and monitor the control, which specific best practices should be followed, what the specific regulations of reference are, and what the differences are when implementing a control from the SOS/POS/IOS perspective. The auditing guidelines provide suggestions, recommendations, and examples of how to evaluate whether CCM controls have been correctly implemented. Given certain control specifications, the document will provide suggestions on which source of evidence should be checked, how to verify the maturity of the control, and how to test technical and procedural controls. Transition Policy. CSA Transition Policy foresees that organizations using the previous version of CCM as the foundation for their compliance programs will be entitled to an 18-month grace period to transition to the new version. This means that companies with the CSA STAR certification or attestation will still be able to use it for 18 months following the new release before needing to transition to the new version. 3.9 Chapter 3 Knowledge Check Review Questions 1. CCM was created to A. Help only large-scale cloud service providers and auditors. B. Support cloud customers building a third-party risk management program in a cloud audit plan. C. Support cloud auditors and consultants in streamlining the auditing process to achieve an ISO 27001 certification. D. Help CSPs mapping organizational, operational, and legal requirements to control objectives. 226 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 226. Answers on page 228. 2. Select all the applicable correct answers related to infrastructure and virtualization. A. The IaaS provider is responsible for the security of the resource workloads. B. The hardening of host and guest OS, hypervisor, or infrastructure control plan is an important control to implement. C. The IV's domain aligns with the recommendation and guidelines included in Domains 7 and 8, Infrastructure Security and Virtualization and Containers, of the CSA Security Guidance. D. Infrastructure systems and network components should be designed to ensure segmentation and segregation. 3. The CAIQ can be used for the following different purposes. Select all that apply. A. Verify, during the service selection process, that a CSP meets the customer's security specifications. B. Monitor that the customer's security controls objectives are met over time. C. Streamline a CSP approach to customer requests for questionnaires during the cloud service assessment process. D. Guide internal auditors during the assessment of the organization's compliance program. 4. The CCM architectural relevance column describes A. The relationship of the question with the CSA enterprise architecture. B. With an X, the applicability of a control to the physical infrastructure, network, compute, storage, applications, data or all these areas. C. The applicability to the network, compute, storage, applications, data or all these areas. D. The applicability to the CSA enterprise architecture and physical infrastructure, network, compute, storage, applications, data or all these areas. 5. The CCM mapping features are useful to select all the correct options. A. Guide organizations in adhering to new standards or regulations. B. Create new controls that an organization can add to its security framework. C. Create links between the CCM controls and over 40 standards and regulations. D. Understand the possible gaps between the existing internal control framework of an organization and the over 40 standards and regulations mapped to CCM. 6. Select all the current statements related to CCM. V4 structure. Select all the correct statements. A. The GRM domain, governance and risk management, will be merged with AAC, audit, assurance and compliance, and renamed governance, risk and compliance, GRC. B. Domain EKM, encryption and key management, will be renamed cryptography, encryption and key management. C. The CAIQ will be merged with the enterprise architecture to facilitate the user determining the shared responsibility model. D. Domain AAC, audit, assurance and compliance, will be renamed ANA, auditing and assurance, and the domain data security and information lifecycle, DSI, will become data security and privacy lifecycle management, DSP. 227 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 227. Chapter 3 Answer key. Correct answers appear in bold font. 1A. CCM was created having CSP, customers and consultants/auditors as a target audience. B. Supporting cloud auditors and consultants and streamlining the auditing process to achieve an ISO 27001 certification is one of the reasons why CCM was created. C. Wrong answer, since CCM is meant to be used to streamline the organization compliance effort, but not to help specifically to achieve the ISO 27001 certification. D. Wrong answer, since CCM helps cloud customers in mapping organizational, operational, and legal requirements to control objectives. 2A. Wrong answer, since in IaaS the security of the workloads is a customer responsibility. B. Correct answer. According to the CSA's best practices, the hardening of host and guest OS, hypervisor, or infrastructure control plan is an important control to implement. C. Correct answer. The IV's domain aligns with the recommendation and guidelines included in Domains 7 and 8, Infrastructure Security and Virtualization and Containers, of the CSA Security Guidance. D. Correct answer. According to the CSA's best practices, infrastructure systems and network components should be designed to ensure segmentation and segregation. 3A. Correct answer. Verifying, during the service selection process, that a CSP meets the customer's security specifications is one of the purposes of the CAIQ. B. Correct answer. Monitoring that the customer's security controls objectives are met over time is one of the purposes of the CAIQ. C. Correct answer. Streamlining CSP's approach to customer requests for questionnaires for service security assessment is one of the purposes of the CAIQ. D. Correct answer. Guiding an internal auditor during the assessment of the organization compliance program is one of the purposes of the CAIQ. 4A. The CCM architectural relevance is used to specify whether a certain control is applicable to the physical infrastructure, network, compute, storage, applications, data or all these areas. B. The X indicates the applicability of a control to the physical infrastructure, network, compute, storage, applications, data or all these areas. C. The CCM architectural relevance is used to specify whether a certain control is applicable to the physical infrastructure, network, compute, storage, applications, data or all these areas. D. The CCM architectural relevance is used to specify whether a certain control is applicable to the physical infrastructure, network, compute, storage, applications, data or all these areas. 5A. The mapping feature guides organizations in adhering to new standards or regulations. B. The mapping feature is not a support to create new controls, but to link CCM controls with other standards, best practices, and regulations. C. The mapping feature creates links between the CCM controls and over 40 standards and regulations. D. The mapping feature helps the organization understand the possible gaps between an organization's existing internal control framework and the over 40 standards and regulations mapped to CCM. 228 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 228. A. The GRM domain, governance and risk management, will be renamed governance, risk and compliance, GRC, while domain AAC, audit, assurance and compliance, will be renamed ANA, auditing and assurance, and the compliance topic will be moved to the GRC domain. B. Domain EKM, encryption and key management, will be renamed cryptography, encryption and key management. C. The merge of CAIQ into CCM won't have a direct effect on the definition of the shared responsibility model. D. Domain AAC, audit, assurance and compliance, will be renamed ANA, auditing and assurance, and the domain data security and information lifecycle, DSI, will become data security and privacy lifecycle management, DSP. 229 Certificate of Cloud Auditing Knowledge Study Guide Copyright 2021 Cloud Security Alliance and Ccak. All rights reserved. Chapter 3 Introducing CCM and CAIQ. Image with the following description, image for page with label 229.